Hey students, this is lesson 6-8. In this lesson, we're going to learn how to name coordinates of special figures by using their properties. And this is a prelude to how we're going to do coordinate proofs. So you kind of have to learn how to name these. Go ahead and do the review, and I'll check back with you. All right, like I said before, in the next lesson, we're gonna learn how to do coordinate proofs. But in order to do that, you have to learn how to come up with coordinates for a figure. And what these coordinates will represent is any arbitrary shape. So what are the coordinates of the vertices of the figure below? ABCD is a rectangle with height of B and a width of 2A. The x-axis bisects BD, or AD and BC, and the y-axis bisects AB and BC. So we know that from this information, if this distance from here to here is 2A, then right here represents the midpoint, so that's half the distance. So the coordinate, and this point right here is 0, 0, right in the middle. All right. So coordinates for, let's start with C. We know that we're going to go a distance of A this way. So the x-coordinate is A. And we know we're going to go down half the distance of the height, and the height is B. So from here to here would be down 1/2 of B. So this is 1/2 B this way and 1/2 B up this way also. This is A going this way and A going this way, that distance. So our y-coordinate would be -1/2 B because we're going down 1/2 B to get to this point C. Now to get to this point B, I'll use a different color, we have to go over A units and up. So over A units and up 1/2 B units. And to get to this point over here, A, we have to go over A units, so that would give us -A, and then up 1/2 B units. And then our last point, we need to go over to the left A units and then down 1/2 of B. So left would be -A and down would be -1/2 B. All right, so that's how you write those coordinates. Go ahead, you try that. All right, we're going to use the variable coordinates in this problem. It says the diagram shows a general parallelogram of the vertex at the origin and one side along the x-axis. What are the coordinates of the point of intersection of the diagonals? So we are going to use the coordinates to help us get the diagonal coordinates. Looks like we're missing this point 0, 0, and this is A. Okay, so we need to find the midpoints. And one thing we should remember is that parallelograms have bisecting diagonals. So if I find the midpoint of one of the diagonals, I actually have the place where they both cross. So pick the easiest points to use, like maybe let's find the midpoint of AC, since A is just 0, 0. And to do that, we're going to use midpoint formula, so we're just going to take 0 plus the x-coordinate of C, which is 2A plus 2B, divide that by 2. And then the y-coordinates are 0 and 2C, add those together and divide by 2. And if we do that, we get 2A plus 2B divided by 2 for the x-coordinate, and 2C divided by 2 for the y-coordinate. That can be simplified a little more. Looks like we have a factor of 2 here, here, and here, so those divide out and we get just A plus B for the x-coordinate, and 2C divided by 2 by C is just Oh, that should be a 2 there, shouldn't it? 2c divided by 2 is c. All right? And we know that that will be the coordinate of the place where the two diagonals intersect. That'll be M. So we don't need to go any further here. If you want to just check it, go ahead and use the other coordinates. Find the midpoint of DB, just to make sure you get the same thing. All right, you try that. All right, you can use coordinate geometry and algebra to prove theorems of geometry. This kind of proof is called a coordinate proof. And we're just going to kind of learn how to plan that here. So in this problem, we're asked to do 4 things. First of all, we want to name the coordinates of a kite with IE equal to 2a along the x-axis. Kn is equal to 2b along the y-axis. So this is 2a. So just knowing that this distance is a, and so is that one. Okay, and then Kn is 2b. So from here to here is 2b. And then from N to T is 2c. And we can use those to come up with the coordinates. So let's go ahead and do that. So part A, our coordinates are N is just 0, 0. K is 0 for x, because it's right in the middle. And then it's up 2b. So do a plus 2b. And so, and then I is on the x-axis, so the y value is 0. And the x-axis is, it's actually a units to the left, so we'll say that's negative a. T is, again, right on the, oh, that one's right on the y-axis, so the x-coordinate is 0. And it's down 2c units, so we're going to call that negative 2c. And E is on the x-axis, so the y value is 0. And it's a units to the right, so that's positive a. So we've named those coordinates. Now we need to state the given and prove. So we're trying to prove that the midpoints of the sides of the kite form a rectangle. Our given is that this is a kite, and I'll write this down here. This is that KITE is a kite, and it has the above arbitrary coordinates. Okay, and then what we're trying to prove is that the midpoints of the kite form a rectangle. The way we're going to do that, and that's part C here, is we are going to use the midpoint formula to find the midpoints of each side. And then to determine whether or not it's a rectangle, we're going to use the midpoints and distance formulas to show that the diagonals of the quadrilateral formed by the midpoints are congruent. So if we have congruent diagonals, then we have a rectangle. All right? All right, I forgot we also will have to show, well, you have to use a slope formula also to show that it is a parallelogram. And if the quadrilateral formed by the midpoints is a parallelogram with congruent diagonals, then it's a rectangle. All right, you try that on problem 3 here. All right, that's it for the lesson. Go ahead and do the lesson check, and we'll talk about this next time we meet in class.